One important way to represent data is through pictures, through graphs, and one type of graph that we have is something called a histogram. A histogram, it is essentially a bar graph having an equal width and no spaces between the bars unless there are actual gaps in the data, right? So if you have a class where there is no one in it, the frequency was 0, then it would look like there's a gap between two consecutive bars because there's really, I think of it as a bar with a height of 0, and so it looks like it's not there. The x-axis, that is going to be your class. And then the y-axis, that is going to be your frequency. Now I say it's your frequency. You can actually create, there are multiple types of histograms. So there are frequency histograms, relative frequency histograms, and cumulative frequency histograms. And so the thing that's going to be different there is this y-axis could also be a relative frequency, or that y-axis could be a cumulative frequency. But we will take a look at the frequency. The bar locations for the x-axis, they are usually labeled with one of the following. So we might use the class limits, the lower class limits, sorry. We might use the class midpoints, or the class boundaries. Here, I'm going to create this using the lower class limits. That's the easiest one to use, I think, if you've already created a frequency distribution. I think the class boundaries really make the most sense. And I'll talk to you about that, about the reason why here in a moment. But we're going to use the lower class limits here. And we are going to use, we're going to roll through an example of this. We are going to create a frequency distribution, a frequency histogram, sorry, for the number of calories in beef hot dogs. And we are using a data set that, if you look back into the video I made 2 videos ago, you will see when we created the frequency distribution there. But let's look back to that distribution that we had. Here's that frequency distribution. Here's the important information. And so our frequency distribution right here. And so from 110 through 121, that frequency from 110 through 121, that frequency is 1. And so we are going to, from 110, we're going to have a frequency of 1. From 122 to 133, we had a frequency of 2. And so we're going to create a bar with a height of 2. Our next one had a frequency of 3. We'll go back and look at that. I just happened to observe it when we flip back. Right, so our next one had a height of 3 right there. Right, so there's our height for the third class. Our fourth class is going to have a height of 6. That's our height of 6. Our fifth class has a height of 1. And then a height of 3. And finally a height of 4. Let me flip back just so you can see those again. Right. So we see our height of 3. And then we see our height of 4 for our final class. So this is our frequency histogram. Now, the 110, the 122, the 134, 46, 58, 70, 82, and 94, those all come from our lower class limits. And notice that 194, that wasn't actually in any of these. It would have been, if we had one more class, it would have been the next value. All right, so that's our frequency distribution. Not distribution, frequency histogram. Our frequency histogram is shown here. Now here's why I don't like to use the lower class limits, even though I did. This one right here, I know for sure it includes values between 110 and 122, but does it include the value 110? Does it include the value 122? That's not clear from this. And so when you create this, if 110 was a value, it would show up here, but 122 would not show up as part of this bar. It would actually show up as part of this bar. If we use a class boundary instead, it becomes much more clear because none of the boundaries are actually included in either of them. So it doesn't matter whether or not you think about, is this line, is this value right here included in this bar when you have the boundaries, because the boundaries don't show up in any of the classes. They're separating the classes. All right. Next time, we'll take a look at some more graphing things, more ways we can visually represent data. We'll talk to you then.